Good morning, good afternoon, good evening, depending on when you are accessing this content. In this particular video, I'm going to be taking you through the very second lab for HCI Datacom. This particular lab is about creating an interconnected IP networks. It has two parts, part 2.1 and part 2.2. So in this particular video, we are going to be looking at IPv4 addressing and routing, which is part 2.1. In part 2.2, which I'll capture in the next video, I'll be taking you through OSPF configuration. So let's begin. We are going to be talking about IPv4 addressing, how to configure IPv4 addresses, and also how to configure static routes in this particular lab. So the objectives for this particular lab really includes, I'm going to teach you how to configure an IPv4 address on an interface. We're also going to look at functions and meanings of loopback interfaces. You should be able, by the end of this video, to also understand how direct routes are generated and added to the IP routing table. You're also going to learn how to configure static routes and understand the conditions for the static routes to take effect. Learn how to test the connectivity of the network layer by using the ping tool, and we're also going to use the Trasat tool. And lastly, we're also going to learn how to configure static routes and understand the application scenarios. So let's begin by going through the network topology. So we have three routers, R1, R2, and R3, which are gateways of their network. So we need to configure these gateways in order to interconnect these networks that they are connected to. So this is the lab topology. This is the lab topology, which I want us to implement on ENSP. So I'll come to ENSP and create a new topo. I'll click on the router icon on this particular section. Then I'm going just to use the normal router, yes, the normal router with the name router. So I'm going to click on it, then add R1, R2, and R3. So just going to select this and align them horizontally. I'm going to go back just to confirm the interfaces. So we are supposed to do this on G003, R1, and R2. So we can just do that. We click on the interface icon there, we select copper. So gigabit Ethernet 003, 003. And then R1 and R3 over 001. So 001, 001, like that. As you might have already noticed, let me just move these labels so that you can see them better. Okay, so R2 and R3, we are supposed to interconnect them via G004 on R2 and G003 on R3. But look, if I click on copper and then click on R2, this particular router does not have up to 004. So alternatively, I'm just going to change this, but it's not advisable really that you be changing the interfaces that are on the topology, so that you can be able to follow through the lab in a better way. But for this particular instance, please allow me to use G000 on both of them because this lab is not very complicated. Later on, maybe I'll make a video showing you how you can be able to add interfaces on certain routers. So I'm using G000 on both of them to interconnect R2 and R3. Okay, so as we go on to look at what we can add next on this, we can just select that and then we start the routers. Okay, so generally, next time and in subsequent labs, we are not going to be starting from the topology and the basic configuration. So I'll always provide the topology and most likely the basic configuration, which includes the interfaces, IP addresses, the router names, and the router names actually. So next time we won't start from here, but today I'm going to show you this so that I show you how to label your topology so that it can be neat and you can be able to follow through the steps in an easy way because of how you've labeled your topology. So after doing this, I want us to label it with the network addresses and IP addresses for the particular interfaces. So to do that, we need to come here to step 3 and just look at the IP addresses that have been assigned to each of the interfaces. Then we label them. Now, a few things we can note from this. Let me just zoom out a little bit. Okay, for example, you can see if a router is labeled R1, then all its interfaces end with .1. Similarly, if it's R2, then all its interfaces, if it's R3, then all its interfaces end with .3. So really, this is one of the conventions that you're going to realize in this particular lab guide, that in most of the labs, if a router is R4, then almost all its interfaces will end with R4. Now, the other thing you need to notice here is that if we are interconnecting R1, and R2, we are connecting R1 and R2, then this network here is going to be 1, 2. Let me show you. So this is what we mean, that the network between R1 and R2 is going to be labeled 10.0.12. Otherwise, if we are interconnecting router 2 and router 3, then the network will be 2.3. If we are interconnecting router 1 and router 3, then it's going to be 1.3. So once you understand that, it becomes quite easy for you to configure these interfaces, and also quite easy for you to be able to troubleshoot your network in case you've configured a wrong IP address on the wrong interface, for example. Okay, so let's label by following that. So of course, we've said that all interfaces on router 1 are going to be .1. So .1, this one here is also going to be .1. This one is going to be .2. That interface, this interface is going to be .2. .3. .3, like that. Let me just drag it up. Good. So the next thing is to label the network addresses. So for this one, it's 10.0. It's between 1 and 2, so 12.0/24. The network address here is 10.0. It's between 2 and 3, so 23.0/24. And the network address here is 10.0.13.0/24. So that's how we label our topology. Let me move this just a little bit so that it's at the center. Okay, so once we have this, then we can go to step 1 and follow it through. So let's go back to step 1. So step 1 is to complete the basic device configuration. They want us to first change the name of the devices. This is what we did in the very first lab. So they're not providing the instructions here, but we already remember how to do that. So let's do it. So first of all, I'll open the CLI by double-clicking them, like that. Then I'll begin from R1. So I'll click on that particular tab to make sure I'm there. Then I'll move to System View. I can just type that, or I can type, yeah, so just that. Then I can type sys and then tab to get sys name on system view, then give it the name R1 like that. To go to R2, I can press on my keyboard Control Tab to go to the next router, and therefore I can go again to system view, enter sysname R2. Then we name R3. It's very important that you begin by naming, because when you begin by naming, then you cannot configure the wrong configurations on the wrong router, for example, or the right configurations on the wrong router. So sysname R3. So you can always look at the prompt to see how that has changed. Okay, at this particular point, we can now look at step number 2. So step number 2, we are supposed to display the IP address of the current interface and the routing table of the router. This we are going to do on just R1. So the command is display IP interface brief. So let me go to R1. So the command is IP display, which can be written in short like that. IP interface can be written in short as int. Brief can be written in short as that. But just because we're doing this for the very first time, let me just write it in full. So let me clear the screen by right-clicking and clicking on the clear. Then I write that command, display IP interface brief. Enter. Okay, so this particular command provides you with data about the interfaces that are there in your device. Let me take you through this. Okay, so the very first column here gives you the interface name and the interface number. The second one shows you the IP address and the mask of that particular interface. The third one gives you the physical status of that particular interface. Is it up or down? Then the last one here, the protocol column, gives you the protocol status, the protocol status of that particular interface. So just a table that looks something like that. So we can see, for example, we have an interface here whose physical status is up, this one, and another one here whose physical status is up, and another one here whose physical status is up, as well as the protocol status is up. Otherwise, all the others are down. So the very first one is G001. So the physical status is up because we've interconnected it with another router, specifically with R2. On the other hand, we've interconnected this one, G003, with R3. So that's why the physical status is up. On both of them, of course, you can clearly see that we've not configured any IP. We've not configured any IP address. So that's why on this particular column, it is unassigned. Then we have another one here whose status is up, both statuses, protocol and physical, the null 0. I hope you remember what we discussed about this, the null 0, which is a logical interface, whose both physical and protocol status will always be up. Otherwise, the serial interfaces we are having here, the Ethernet, and also G001 and G002, their statuses are down. So that is what we are learning from this particular command, display IP interface brief. Display IP interface brief. So this command can only work on system view. This command also gives you a summary or statistics. For example, the number of interfaces that are up. So we have 3. The number of interfaces that are down, physically down, protocol up, and also protocol down. So these are some of the other information that you can get from this particular command, display IP interface brief. Okay, so that is it about that particular command. The second command we want to look at is the display IP routing table. This particular command, of course, will output the routing table of the router. So let's have a look at it and try and understand what we have here on R1 again. So I'll right click, then clear the screen. Then I'll enter the command display IP routing. I can use the tab to autocomplete it. Routing table. Did they use brief? Let me just check. No, just routing table. Okay, so just like that, then enter. So once you do that, you get the routing table. We already saw this and talked about it. During the just a moment. So we talked about this table during the theory class. The very first column is the destination address and the mask, then the protocol, the preference of that particular protocol, then the metric, which is the cost, then the flags, then the next hop, and lastly we have the interface. The interface, which is the interface through which that particular packet will be forwarded to the next hop. So really, we can see that when we use this command, display IP routing table, then we get at least two. We have at least two entries in the routing table by default, even before we configure any addresses. Now, this particular entry, if you can remember, this particular range of IP addresses is what we call the loopback address. The loopback address is an address that is used to, most of the time, to test the functionality of your interface or network interface card. Why? Because when you send a packet to this particular address 127.0.0.1, for example, then your network card will simply resend it back to your computer as if it's coming from a different device or from a different network. So it's like you're trying to send to yourself so that you can see whether you can be able to send and also receive successfully. So that is what the loopback, that is what the loopback interface really does. So anytime you want to test whether your network software is working, then you can do a ping, for example, to this particular address, 127.0.0.1/32, for example. So you can see that anytime you do that, then the next hop for that particular packet is the same address. So simply sending to yourself to see whether you can be able to also receive. In most operating systems, this particular address is used to refer to what we call the local host, meaning you are referring to yourself. And sometimes, for example, it is used, for example, in like WAMP server in Windows to access a particular directory or website that is hosted within your local machine. So it's also called the local host. Let me just demonstrate that, for example. So if, for example, I write ping 127.0.0.1, then I should be able to get replies. And the reply, I'm getting it from this guy. So it's myself. So the entire range of 127.0.0.0 up to 255, the entire of that particular address range is reserved for loopback and is majorly used for testing. And we also have other functionalities for loopback addresses, which we are going to look at. Okay, so I just want to insist on something here, that the IP address of the in loopback interface cannot be changed or advertised using a routing protocol. Please remember this. Remember that the IP address of the in loopback 0 cannot be changed. By in loopback we mean this guy. You see, the interface through which we are going to send out that packet. It's called in loopback 0. In loopback 0. So that is the particular logical interface whose IP address is this. We are sending to ourselves, local. It's called a local host or a loopback, in loopback 0. Okay, so let's go on to step number 3. Step number 3, we are required to configure the addresses for the physical interface. So let's do exactly that. We have already labeled our topology, and therefore we are simply going to be following that particular labeling to configure this. So the very first bit is to go into the interface. We can begin with interface G0/0/3, which is connected to R2. Then we configure the IP address using the command IP address. Then the IP address 1.1. Then we can use 24, just like that. Then enter. So when you do that, you're going to get some log information, which is information about what you've just done. So for example, this one I just want to read from here that the current, let me see, okay, here, that for this particular link, the line protocol IP on the interface that has entered the up state. So the protocol status has now changed into up because we've just configured an IP address. So you'll always get this kind of feedback information, but in a while I'll show you how to disable it, because sometimes it can be destructive if you want to configure other parameters. Now, just to confirm on an interface whether you've configured the correct IP address and any other parameters, there's a very powerful command, simple, is called display this. So if you're on an interface view and you type display this, you'll be able to get any configurations that you've done on that particular interface. So that's how you can always confirm that you've configured the correct IP address, for example. Okay, there are two ways to go into the next interface. One way is I type quit, I go back to the system view, then I enter int G0/0/1, for example, like that. And I'll go into G001. Otherwise, if you're on G001 and you want to go to G003, you can just type inside there like that instead of quitting. So that one is a little bit faster. So now let's edit G001 and assign it an IP address. So IP add, that is the short form for that, 10.0.13.1. Then you can do 255.255.255.0, or you can simply use the mask length, which is a little bit easier to type and faster. So if I do that, we can see that the line protocol of that particular interface has now changed to up. Okay, so let's do the same to R2 and R3 very fast. So I'll simply come here, clear, go into system view, then go into the interface G0/0/3, then IP address 10.0.12.224, enter. Then I'll go into int G0/0/0, IP address 10.0.23.224, enter. Then I'll go to R3 now, clear my screen. Then I do then I go into system view. Then I go into the first interface 0/0/0 IP address 10.0.23.324. Then I can go into int. You can always do tab when those messages come out. So int G0/0/1. And if you're wondering where I'm getting this, remember I am just looking at the background, my topology here and the label. So now I'm configuring this particular interface here. I hope you're also able to see it. So that's why for my CLI, I always configure the transparency so that I can be able to see the background and be able to configure especially the interfaces quite fast. So int 001, we are supposed to configure it with the IP address 10.0.13.324, like that. So I'll quit now. Once you're done with that, then we can always use that particular command that we used earlier, display IP interface brief. Sorry, display IP interface brief. So we can see, for example, on R3 we have configured G00 and G001, and you can see the IP address that we've configured just to confirm whether they are .3, both of them, and whether we've connected to router 1 and router 2. And you can also confirm the physical status and the protocol status have both changed to 1. So that is how you also confirm that you've configured the correct IP addresses. So after confirming, of course, you can always do this. You have to quit on all of them. Display IP int brief br. So we can see on this one, we have configured G001 to connect to router 3 on with that particular address, and this one to connect to router 2 with that particular address, and the statuses are both up on R2. Let's confirm whether we've configured the correct one. Quit, then display IP int brief, like that. So we can see G00 connected to R3 is .2, good. We can see G003 connected to R1, and we can see that it's a .2. Oh, we are on, yes, we are on router 2, so that's okay. Okay, so I think we are good. We are good to go. So the next thing should be really to test the connectivity using the ping tool. So we want to ping the interface on R2 from R1 and see whether we are going to get replies. Okay, so let's do that. So on R1, let's clear this. We do ping 10.0.12.2, like that. So if I press enter, you can see that indeed we are getting replies. We can also ping R3, which is on 13.3. Are we able to ping it? Good. So at least right now we've tested this particular connection, this one, and this connection. Can we now test this one? So we can go, for example, to R2 and ping 10.0.23.3, and indeed we can confirm that we are getting successful replies. We've sent 5 requests we've received 5 replies. So that's how you test for connectivity, to confirm connectivity between interfaces. Okay, so let's move on. The other thing we're supposed to do is to now have a look at the routing table of R1. Before we had looked at that particular routing table, the only thing we saw is the in loopback address 127.0.0.1. So we want to see whether we have other networks that have been added on this particular router after configuring the interfaces. So display IP routing table, enter. So ignore these ones. These ones are actually supposed to be after each of these. So for example, gigabit Ethernet 0/0/3. So they've just been made to go to the next line, but it's supposed to be here. It's supposed to be here, that one, and so on and so forth. But generally, you can see that we have these particular networks that have been added. We have these particular networks that have been added to our routing table. So let me try and explain them. The very first thing that is added to our routing table is the network address. The network address of that particular interface which we have configured with an IP address. So the network address between R1 and R2. This is the network address, and this is the mask for that particular network. We can see that for the protocol, that is a direct route. We can also see that if we want to send anything to that network, then the next stop is our own interface. Our own interface, gigabit Ethernet 0/0/3. So we have to go out through that. Now, the next thing that is added is this one here, which is now the IP address of that particular interface, which we've configured. Our interface, gigabit Ethernet 0/0/3, this particular interface here. We've configured it with this particular IP address. So that's the next thing that is added. And similarly to the connection to R3, an entry will be made to the routing table for the network address and also for that particular interface address, 10.0.13.1. Now, I'd like to point out something about this particular entries. It's a little bit different here, but generally, 3 direct routes are automatically generated for each interface after the IP addresses of the interfaces are configured. So the first one is a route to the network where the interface resides. So that is what we've seen. So this is the route to the network. It's simply the network address. The second one is the host route to the interface. So what they're calling host route here is simply the address of that particular interface. This one here. Then the last one that is supposed to be added but is not displayed in our example is the broadcast address for that particular network address. So the broadcast address, if it were to be added, then it will look something like this. It's simply the broadcast address for this particular network address. So those are the 3 direct routes that most of the time will be generated. For the host routes, they will always end with a 32-bit mask. So both for the interface address /32 and for the broadcast address, then it will also end with /32. So that is how we display the contents of the IP routing table. Okay, so let's now look at the loopback interface. How to, on step 4, how to create a loopback interface. So we want to create a loopback interface according to this particular table. So we want to configure LoopBack0 on R1 and give it an IP address 10.0.1.1/32, and similarly we create on R2 and on R3. Now, just like the physical interfaces, loopback interfaces also need labeling. So most of the time, you will be writing something like maybe loop0, or you even write it in full, loopback0, depending on how you want it, then full colon, then the IP address. Then the IP address. You can always, for example, copy that so that you can easily paste it. So, for example, this one is supposed to be .2, and this one here is supposed to be .3. So on these labels, you can always double-click them in order to edit anything that is inside it. So let me just place them. So we are supposed to create a loopback0 on each of these. That is what you're supposed to do, and give them these particular IP addresses. So let's do that. Just before we go there, I hope we remember that loopback interfaces are logical interfaces, and they are usually manually configured, meaning you have to create them. So they do not exist physically, like G001, G002, or the Ethernet ports or the serial ports. So you have to do that. Now, the other thing that you need to know, so we say they are manually configured. Manually configured. Number 2, their status. We say this: physical and protocol status are always up. So in general, they are used to exchange data. But the purpose, particular functions of the loopback interfaces, for example, is to identify and manage a router. Can be used to identify and manage a router. Loopback interfaces are also used in OSPF. For router ID. So we're going to learn, the next topic we're going to learn is OSPF. You're going to understand how OSPF acquires a router ID from the loopback interface. It's also used to improve network reliability. Now, some of the protocols are going to be using loopback interfaces, because loopback interfaces will never encounter any physical problems. So you cannot go down like a physical interface can for example, experience some electrical fault. No, this one has been created using the software, so it will never go down, and that's why we say it's used to improve the network reliability. And that's why protocols such as BGP, for example, and many other protocols use these kind of loopback interfaces. In this particular example, these loopback interfaces that we are creating are simply used to simulate clients. So what that means is, let me see if I can draw, for example, a line here. We simply want to simulate clients, meaning we want to assume, for example, that we have an interconnection to that network, and this one has an interconnection to this network, and this one has an interconnection to this network. So that we can be able now, for example, to do pings and be able to see whether we can be able to reach that particular network. So I'll just use a line to draw. So that is how we are using loopback interfaces in this particular lab. simulate particular clients. So let's create the very first logical interface that we are creating manually here. So how to do that? You simply type the keyword interface, then loopback, then the number. So if I do question mark here, you can see that we can create about 124 loopback interfaces. So you can create loopback1, loopback2, loopback3, etc. So we want to use the very first one, so loopback0. Then you give it an IP address, just like we did with the others. Oh, these messages are coming up again, so let me deal with it. But whenever it comes up and you had typed a command maybe halfway, you can always press the tab key and it will show the command that you have typed. So this is R1. We're supposed to configure 011/32. That's another thing that I need to mention here, that loopback interfaces normally they're given the mask 32 because they cannot be in any other subnet with any other physical address, for example. So we just want to use this particular IP address and not, we don't want to use slash, for example, 24 because we'll have wasted how many? 250 something addresses. So that's why we give it /32, meaning we're just using this particular address only and not any other. So most of the time we'll be assigning loopback addresses with the mask 32. So if I can do enter, I can do display this, for example, to confirm whether we've configured the loopback0. It's there, and we can see the mask is 255.255.255.255. Okay, so let's do the same on these other routers. So you have to be on system view, interface. You can just type loop0 in short, IP add 10.0. Oh, I didn't handle this. So let me quit. Now there's a command called let me quit again to go back to user view. It's called undo terminal monitor. So undo terminal monitor is used to disable the messages that you get. The messages that you get after you've done certain configurations. Now, if I do question mark here, undo terminal, then question mark. Now, some of the messages that you get include debugging information, also logging information, that is what you're doing and how much time you're spending, and also trapping information, which is how the statuses, for example, are changing for the interfaces and so on and so forth. So if you don't want to get these messages, you can always type undo terminal monitor so that you can disable what we call the information center from giving you this feedback every time you configure something. Unfortunately, sometimes it expires and therefore you have to repeat the command undo terminal monitor. But the short form is also easy, UTM space U space T space M, like that. So it's quite easy to undo the terminal monitor. So if we press enter, you can see that the current terminal monitor is off. So we can go back and configure an IP address on int loop0. Oh, sorry, wrong parameter, 0, like that. So display this. We don't have an IP address, so IP address 10.0.1.232, like that. Then we can go to R3, clear, enter system view, int loop0. Then we do IP address 10.0.1.332. Enter, like that. So that's how we configure a loopback address. Quit. Undo terminal monitor, UTM. Okay. So if we type display IP interface brief, you see that we have a LoopBack0. We've created LoopBack0. We can see that the status is up both for the protocol and the physical status. So you can also confirm here. We can also confirm on R2. The other way you can confirm is display IP interface, then the name of the interface and the number. So for example, LoopBack0. So you'll only get details about that particular interface. So you can see that the current status is up, protocol status is up. If we go down a little bit here, you can see that we have the internet address, which is the IP address that we've configured for this particular packet. Okay, so let's move on. I'll do Control C. Otherwise, I can tap Enter. I can tap Enter on my keyboard to go on that list. But I can also press Control C if the list is too long and I want to go back to the prompt and maybe type another command. So let's look here too. Have we configured this? Display IP int brief. Okay, so we've correctly configured LoopBack0. Okay, so let's go back to the instructions and see what we have here. Okay, so now we want to do a ping. We've already displayed the routing table and we've seen that. Oh no, we need to display the routing table. We haven't done that. So let's just do that on R1 to see whether that routing entry has been added to the routing table. So display IP routing table. So on the routing table, we should be able to see the 10.0.1.1/32 a loopback address, and you can see that the next hop for a loopback interface is the loopback address 127.0.0.1. So that entry has been added on the routing table. Now the next thing will be now to test the connectivity between the loopback interfaces. We test the connectivity between the loopback interfaces. So if we do that, what do we get? So let's ping from R1. We ping the loopback interface. From R1, we ping the loopback interface of R2. So ping 10.0.1.2. So we can't be able to get to that particular network. Also from here, we can ping 10.0.1.3, the loopback interface of R3. And by loopback interface here, we just mean we ping this network that is connected to R3, because this loopback interface is being used to simulate another network or another client that is on a different network but connected to R3. So if we press Enter, again, our request is going to time out. Reason being, these two addresses or networks have not been added to the routing table. So R1 does not know those two networks, and that's why the ping cannot be able to go through. Okay. Okay, so just a moment. Okay. So we can't be able to reach the loopback interface of R1, neither can we be able to reach the loopback interface of R3. Reason being, we do not have those networks installed in our routing table. So display IP routing table, enter. We can't see anywhere 1.3 or 1.2. We don't have it. 10.0.1.3.1.2, not anywhere here. So we can't find it. So what to do? In order to be able to reach the loopback interfaces of these particular routers, we need to configure static routes. So we want on R1 to configure a route to the loopback interfaces of R2 and R3. So let's do that. To do that, we use the command IP route static. Then we enter the destination network, so which is 1.2.32 and the mask. So for router 2, then the next hop in this case is 1.2.2. This particular interface here. So if we want to go, is what we are saying, that if we want to go to this network from this network, then we have to send that particular packet to this next hop from the router. So we have to configure the address, the destination address, the mask, and the next hop, which is this IP address .2. So that's what we want to do. Okay. So I can press enter, then do the same. Route static 10.0.1.3. 32. The next hop will be 0.13.3. So that's how we create a static route to the loopback interface of router 3. So enter. So now, if we do display IP, UTM, display IP a routing table. So on R1, we can see now that we have this particular, that particular network that goes to R3, the loopback interface of R3. We can also see that we have 10.1.2. Where are you here? Static. You can see that both of them, we've configured them statically. So static. So now, remember, communication is bidirectional. We've only configured one-way communication. Meaning we've configured LoopBack0 to be able to send packets. The loopback from there to be able to send packets to that loopback. We've also been able to configure this to send packets to this one. So now we need to do this, configure this one. We also need to configure this one, like that, the way back. So let me demonstrate that. If I do a data capture, for example here, if I right click, then start data capture, then I do a ping from R1 to the loopback of R2, you'll see that indeed R2 is going to get the request. So if I do ping 10.10.0.1.2, so I'm pinging the loopback of R2. If I do that ping, oh, sorry. Okay. Okay, so we captured everything, and we actually got a reply after configuring that particular static, and let me explain why. So we've gotten a reply after pinging this guy. We've gotten a reply, and the reason is because anytime we do a ping, let me show you. So I hope you understand this very clearly. Anytime we do a ping from this router to this guy, we do a ping like that, the source address of that particular ping will be the output interface. In this case, the source will be this particular guy, G003. The source will be 10.0.12.1, and not this guy, for example. So we want to make sure that this particular packet comes from this guy. We simulate as if it's coming from this guy and not from this particular interface. So I'm going to show you how to do that. But first, let's confirm on Wireshark that the source address of those requests indeed come from 10.0.1.2. So let's see. If we look at one request here, you can see that the source address is 10.0.1. You can see the source address is this one, which is the output interface. You can see the source for all the requests is this one. But now we don't want to ping with this one. We don't want to ping with that particular interface. We don't want to ping using this interface. We want to ping using the loopback address so that we don't get a reply. The reason being, we're able to get a reply when we ping using this one because this one already has that network. It already has that network in its routing table because it's a directly connected network. So let's do that. Let me clear this entry in Wireshark. Capture, restart capture, continue without saving. Okay, so how to do that? You do that using the ping option command. So let me just show you. We have several options: -A, -C, etc. The particular one that we're going to see, I encourage you to have a look at a few of them and expect a question for that in the exam. But the particular one that we're going to use in this instance is -A. It's used to select the source IP address. So, as I've said, the default is the IP address of the output interface. If you do ping and you don't select the source, then the default source is the output interface, where that particular packet is coming out from, going to the destination. And we've seen that already on Wireshark. So let's use that particular command. Ping -A, that particular option, not command, option. So -A, then we want the source to be 0.0.1.1. So we want that to be the source. Then the destination, we want it to go to 0, loopback2, loopback for router 2. So that's the destination. So that's how we use this command. If I do, for example, question mark there, you'll see it says the source IP address. So 10.0.1.1. If I do question mark, we have several things here. Specify the number of echo requests. We don't need to do that. But anyway, let me just go ahead and do the destination 10.0.1.2. Okay. Oh, my Wireshark has not been able to capture that. Let me just restart the Wireshark and do data capture again. So start data capture. I want you to see that indeed we are going to send the request, but we are not going to get the reply. So let's demonstrate that again. Let's try that out again. So let's send a request to that particular guy. Whoop. So you can see indeed on Wireshark, you can see indeed on Wireshark we are sending 5 requests. We are sending 5 requests to this guy, and you can see that this time, because we specified the source is not 10.0.12.1. The source is the loopback address 1.1. So it simply means that we need to configure on R2 the way back. We've configured on R1 how to go this way. We've configured on R1 how to go this way. So now on R2 we need to tell it how to send the reply, because in R2's routing table, R2 does not have this network for the loopback interface. It does not have this network. It does not have this one. So let's do that. Let's configure the static route on R2. Clear. So system. Then the command will be IP route static destination address 10.0.1.1/32 next hop 0.12.1, like that. Similarly, we can create a static route UTM and do terminal monitor. We can configure a static route to the loopback interface of R3. So route static, then 10.0.1.3, then 32. Next hop will be 0.23.3, like that. Enter. So once we have that, we can do display IP routing table. We can see that we have a static route to the 1.1 loopback and 1.3 loopback. Okay, so now indeed if we repeat the ping from R1 to R2's loopback, here I'm using the history, so I'm not going to type this command again. If you press the up and down arrow on your keyboard, you are able to go through the history table, the commands that you've recently typed. So I'm just doing that in order to access the previous command I had typed, which is ping -a. Then I specify the host 1.1, then the destination 1.2. And now if we press enter, we should be able to get the replies. But R1 cannot be able to ping. We cannot be able to ping the loopback of R3 if I write .3, because R3 does not know this particular network. So again, we need to go to R3 in order to configure the static routes to R1 and R2. So let's do that. So on R3 again, we do terminal monitor IP route static 10.0.1.1. The next hop will be 10.0.13.1. then to static 10.0.1.2 32. The next hop will be 10.0.23.2, like that. So once we have that, then we can be able to ping. We can be able to ping negative A 10.0.1.3. We want to ping 10.0.1.1. So we want to ping from the loopback of R3 to R1. So we should be able to get the replies. We can also write .2 to ping the loopback of R2. So we can see that now we are able to reach all the loopbacks. Okay, so let's look at the instructions and find out what's next. We've tested the connectivity. We've been able to do that. Okay, so now we're on step 6. So we want to configure a path from R1 to R2 via R3 as the backup path from LoopBack0 of R1 to LoopBack0 of R2. So let me explain that. So what we want to do is, we know that to go to our loopback of R2, we have two options. We can either go through this path. Alternatively, we can go through this path. Like that, then like that. So those are the two options we have when it comes to going to this guy. So far, what we've configured is this. We've configured this one. So what they're telling us now is, can we configure a backup? Can we configure a backup route via R3 to this one, from this one? Can we configure that? We want to configure a backup via R3. So let's do that. Okay, so to do that, we need to configure static routes on R1 and R2 whose next hop will be R3's interface. But now we use the preference option to give it a higher preference value so that it cannot be installed on the routing table. So let's go to R1. So I want my background to be that. So on R1, so on R1 we want to say IP route static. So we want to say, if you want to go to the destination network 1.2, like that, 32, then forward it to router 3, so 13.3, like that. But now we want to give it a preference value that is higher than the default static route preference of 60. So we give it 100. So like that. We give it 100. So if we do display IP routing table, display IP routing table, we are not going to see this. We are not going to see this having the next hop of .3. We can't see it because this one is the preferred route. This one is the one that has been added. You can see the preference. This one is the one that has been added to the routing table. Otherwise, this one, if you look through here, there's no static route that has a preference of 100. It cannot be added. It cannot be added because we have a better one. We have a better one which has a preference of 60. So the other one we just configured cannot be added. Anyway, let's configure the backward route. how to get back to R1 via R3. So let's do that here. So again, IP route static destination. We want to go to 1.1.32. The next hop, we want to use 23.3 like that, but we give it a higher preference. You can just write preference short form as pre-100 like that. So again, if we do display IP routing table, we can't get this destination with a preference of 60 is the one that is installed. Otherwise, we have nothing for 100. So right now, as it is, if we do a ping, or not really a ping, but let me see, what do I want? Oh, okay. Okay. Okay, so instead of using ping, we can use Trasat. So Trasat to find out the router. If we ping from loopback, the loopback of R1, we ping the loopback of R2. If we press enter, which router is it going to pass through? So you can see that if we ping from R1, then that particular packet is going to be sent to this interface on R2, 10.0.12.2. Simply going to be sent here. Then this guy is going to deliver it to that particular loopback0. Now, what we want to do is to simulate a network failure. We want to simulate a network failure. How so? We want to shut down this interface on R1. We want to shut down this interface on R1 so that the backup static route can be added to the routing table. So let's do that. So I hope that is clear that we simply want to shut down this. We want to shut it down so that the other route can now be added. This one can now be added. This route we just configured can now be added to the routing table. Okay, so let's do that. We come here, then we do we get into that interface. So interface G0/0/3. Oh, I mistyped that command there. G0/0/3. The command for doing that is shut or shut down in full. Shut down, enter. So when you do that, you can see that we are being told that the status of that particular link now is down, has entered down. Interface has entered down state. Okay, if we display the routing table, display IP routing table, we can see now, if you want to go to the loopback of R2 from R1, you can see that this particular route has been configured manually with a preference of 100, and that particular packet will be sent to R3 on 10.0.13.3 as the next hop. So if we now do a ping, ping, we want to ping .2. So if we do a ping, we should be able to ping it even though we've shut down G003. And now we can use Trasat to find out how it's going. So Trasat -A, then we specify the source and the destination. So we can see that at first this particular packet is being sent to router 3, then sent to router 2 on 23.2. So that simply means that we are sending that packet through this route, like that, then like that. So it is important to insist on the fact that only the optimal route is added. Only the optimal route is added to the routing table. How do we know that? Depends on the preference, number one, and number two, the cost. So if there's a better route, then that route will be added. Otherwise, the other one will not be added to the routing table. Okay, so let's look what next. We've said that. Trace the path. We've said that. Okay. Okay, so let's now go to step number 7. Configure default routes to connect the LoopBack0 interface of R1 and the LoopBack interface of R2. Configure default routes to configure the LoopBack interface of R1 and the LoopBack interface of R2. So remember the concept of default routes. That's what we want to practice here, default routes. So to do that, we're going to begin by restoring the interface G003 by using the command undo shutdown. Then after that, we are going to delete the static routes from R1 to the LoopBack of R2, both of them, the backup and the primary route. We are going to delete them by using the undo command. The reason as to why we are doing that is so that we can configure a default route from the LoopBack interface or on R1 to the LoopBack interface of R2. So let's do that. So on R1, we first of all go to int G0/0/3. We undo shut. So now it's up. We quit. Then we can undo this one, this command. So undo, like that. Then we can also undo IP route static 10.0.1.2 32 10.0.12.2. So we also had that one. So we have deleted the static routes that we had configured to the LoopBack of R2. If we do display IP routing table, we should be able to see that we don't have any static route to R2. We only have a static route, single one, that is going to R3, to the LoopBack of R3. So we don't have it. So right now, if we do the ping, for example, if we do the ping from the LoopBack of R1 to the LoopBack of R2, we can't be able to access it. Now, to be able to access it, we can configure a static route. We configure the static route by using the command IP route static. Then we use the default. We use the default address 0/0/0, the mask of 0, then the destination. The next hop, the next hop. So we are simply telling R1, if you get a packet, you check through your routing table, you don't have that destination network, then simply send this packet to R2. So R2 will know how to deal with it. So that's what we are doing here by configuring this static route. So if I press enter, then I do the ping again. This time we get a reply. This time we get a reply, courtesy of this, the default static route. Default static route, which is configured using the special IP address called the anycast IP address. Anycast IP address 0.0.0.0. Okay. Oh, display the routing table so that we see the entry. So now it's important that I do that and clear. So display IP routing table, enter. Good. So we can see that indeed we have the default static route whose next hop is the interface on R2 10.0.12.2. Okay, so we already tested that. Okay, so ladies and gentlemen, indeed we've reached the end of this particular lab. Thank you very much for staying through. I now want to show you how to save your work, how to save your configuration. So how to do that? You need to quit and go to the quit and go to the user view. Then you type save, then Y, like that. Then we can go to the next one, save, Y, enter. Then you can go to R3, save, Y, enter. Y for yes, like that. So when you do that, then you've saved your configuration. Next thing you need to do is to save your topo, which is the very first thing actually you should have done. We should have done. So you click on save, then you choose a location where you want to save your document. So for example, I want to save my document on my backup. I have a folder called hcia.com training labs, and this one is maybe lab 2.1 IPv4 addressing and configuration and routing configuration, something like that. Then you click on save. So once you've done that, then you can be able to create a new topo, and next time you'll be able to open it. So anytime you click on open or you want to close the NSP, it will ask you, do you want to save? Just click yes, and it's going to shut down your devices, remove them, and now you have a new topo. So if I want to reopen my project, I click on this third icon here, open. Then I go to the location where I saved it, then I double click to open it. So once you've done that, you can select all of them, then click on start to start the devices. If you have a slow machine, always make sure that you start each device one at a time to avoid overstraining your computer. Okay, so if I open the CLI, so anytime you see the hashtags, it simply means that the computer is still, the router is still starting up. Anytime you see the hashtags, it means that the computer is still running up. So you can see that the name remains as R1. Otherwise, you know that you've lost configurations if the name has gone back to the default Huawei. Otherwise, if the name has remained, probably all the other configurations have remained, like display IP, interface, brief. You can see that indeed all the interfaces I configured are there. All the interfaces I configured are there. Now, just in case you lose your configuration after saving your work the way I've shown you, can you please try and save your work on a different partition? On a different partition of your hard drive. So if you've partitioned differently, try and save it just on a different partition. Or if you have the same partition, try and save it on a different location. So always make sure you do that, so that in case you're not able to complete a lab at a given time, you can just come back and pick up from where you left it. Now we have a quiz here. We have some 2 questions. Actually, there are around 3 or 4. I want you to go through them. Then can we have that discussion on the answer? Can you please comment? Can you please comment and tell us what the answers to these questions are? Then I'll be able to maybe reply to 1 or 2 people on whether their input is correct or the correct situation, or which the correct situation is. So ladies and gentlemen, thank you very much. Thank you once more. Asanteni sana. Let's meet next time. Thank you.